Measures of central tendency. So it is a very important concept, a very important topic carrying a huge marks in class 9, 10th as well as in the 11th. Let's begin the class under my project Adhyayan Bharat Mission, an initiative to render free and quality education for all. So the first one is, what is data? Data is the collection of numerical fact. Okay, any collection of numerical facts are called data. Okay, this all are from the Greek words. Okay, so let's discuss what is measures of central tendency. Before that, let us know why we need to calculate or find this value. According to a data has certain values which may vary or extend or differ. So in order to measure this variation, this extension and the differences, we need three orders to measure that. The first one is the averages, or what we are going to study it is the measures of central tendency. The second one is dispersion, under which we have to study for standard deviation, mean deviation, median deviation, okay, range, interquartile range, coefficient of else what, okay, which will be this is important. This topic is important for the class 11th one and for all type of degree courses. And the skewness, moment and kurtosis, it is for the graduation. But we will move on this topic. We will discuss this later on for the class 11th. I will make a exclusive video on them. So before starting measures of central tendency, let's have the definition of measures of central tendency. What is this? That value of data around which whole observation of data revolves. It occupies a position. Suppose these are the datas. Okay, these are the datas, and there is a value of this observation of data around which this occupies the a position around which these datas are revolving. Like you say that it is a sun, measures of central tendency is sun, and it is the solar system. The planets are revolving, the moons are revolving, likewise that. Okay. So this measures of central tendency have, or the averages have, two types. First one is the mathematical averages and the second one is the positional averages. In mathematical averages, we have to study arithmetic mean, that is AM, that is denoted by X bar, the geometric mean and the harmonic mean. These two are important for the graduation students, or the students. Don't get confused with what has been taught in the mathematics of GM or harmonic mean. It's quite different. For finding this geometric mean and harmonic mean, we have to know the logarithm table. We have to use the logarithm table and the anti-log tables to find the values related to GM and HM. So the next one is the positional averages, which is we call median, which is denoted by capital M, and mode, which is denoted by Z. Earlier I have said you while teaching you about the integers for the number system that Z will be denoted as mode. Okay, don't get confused with this one. So let's begin the first part of arithmetic mean. Before beginning that, let's have some concept regarding some basic of statistics. The data, that is raw data and array data. Raw data, an initial collection of data without any arrangement. Just likewise, we go to door-to-door survey in our locality to find the number of children in the families. This is raw data. And what is this arrays data? When we arrange it in a certain order, whether ascending, descending, or on the basis or grouping, that is called array data. So let's classify about the data. Data can be classified on the basis of two parts. One is the collection of data and another is the grouping. The first is collection of data, that is primary data, and what is secondary data. Primary data, when we initially collect some new data, it is called primary data, and when we take it from the sources of any primary data, that is called secondary data. For example, when you go for enumerating to your locality about the weights of the or the BMI index of the families, that is the primary data. And when this data is collected by any organization and we use that data for further analysis, like you have seen while reading that economic survey, okay, NSSO, these are the sources of secondary data. They provide data that are properly classified, analyzed, and that can be further used for the studies. So the next one is the grouping. On the basis of grouping, there are two types of data, that is group data and ungrouped data. In ungrouped data, that is individual series, okay, and for the group data, it is the continuous series and discrete series, okay. Discrete series, individual series doesn't have no frequency. There is no frequency in the individual series, so that is why we couldn't say it as a grouped one. For continuous series, there are two types of data, that is inclusive series and exclusive series, okay. In inclusive series, the upper limit, for example 0 to 10, in inclusive series, this part and this part both are included. It is called lower limit and it is called upper limit. But in exclusive series, say 0 to 10, this is included, but we can't include this. We can't include this because we have to exclude this. We could take up to 9.99999, but we couldn't take the data which has been mentioned in as 10. Got it? So now the first part is mathematical average, that is called arithmetic mean, which is being denoted by x bar. So formulas for the individual series, I have explained the individual series, discrete series and continuous series. Remember, in finding mean, we didn't need to convert inclusive series into exclusive one. We could find it easily with some restrictions. But to find mode and to find median, we obviously needed the conversion of inclusive to exclusive, which we will be discussing in our next video when we study the median and the modes. So for example, the formula is arithmetic mean equals to sum total of all observation by number of observation. For example, there is given the marks of maths of 10 students are 63, 74, 46, 91, 48, 33, 89, 94, 65, 52. We add it on and let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 peoples. So we divide it with 10. On adding it, we get 655 and it's the answer is 65. Okay. Now let's discuss about the formula of discrete series. We had said it earlier that in discrete series there is a frequency and in individual series C there is no frequency. So it is a individual series. This is how we could say that a series is whether individual or discrete. The first thing, that there is a lack of frequency. So for this, the formula is x bar equals to sigma fx into f into x by sigma f, where f is the frequency of the data, x is the size of data, and this is sigma, or we could say the summation, means sum total. So let's see an example regarding this. So there is a data given of 10, 20, 30, 40, 50 and it's 7, 8, 3, 11, 8, 4. So first what we have to do, fx, frequency into x. It's 70, it's 160, 90, 440, 400, 240. We add it on, that is called sigma f, that is 41. Sigma summation of frequency, and this is the summation of frequency into x, that is class. So 70, 160, we add it on it 1400, and the formula we implemented. Always remember to find the data or the answer in 3-digit number and then round it off. See, I have done it. It is the sign of equivalent. Okay. So it is the direct method to find the discrete series mean. So there is a shortcut for method, that is we call assume mean method, to find the mean of a data. Okay, the formula is assume mean plus sigma x minus a into frequency by sigma f. So let's see an example of regarding this. So the same data I have taken out, what we have taken for the direct method, that we have taken for the assume mean method. So first we took any number from here. You could take any number from outside. Suppose you could take 1 lakh, but for convenience it is being recommended to take the number within the series. So I have taken 40. You could take 20 or 10. The answer will be as it is. So what we have to do, this assume mean, we have to subtract it from the x. So 10 minus 40, it gives minus 30. 20 minus 40, minus 20. 30 minus 40, minus 10. 40 minus 40, 0. Likewise here. Then we multiplied this both. And the answer obtained is said to be sigma f x minus a, that is minus 240. Beg a pardon for the overwriting. The summation of frequency is 41. So assume mean. You have a query is why we add this one? Because I have subtracted from each of the series, I have subtracted this assume mean. So I have to add all along here. I added it on and put it out the values there, and here the same 34.15. Got it? So this is the process to find the arithmetic mean by shortcut method for discrete series. Now let's move on for the continuous series. So before telling you about this, there is inclusive series and exclusive series. There are the all formulas that are common for that. We have 3 formulas to find the questions of continuous series, that are direct method, assume mean method, step deviation methods. So first discussing about the direct method. The direct method, let's first discuss about what is this. This is mid value. What is this mid value? Is the sum of lower limit plus upper limit by 2. That gives the mid value. Here we have to find it mid value, which is denoted by xi. So we have a questions of marks of 0 to 10, 10 to 20 and falling going to 50 to 60. And there are a number of students, that is the frequency given off. The first one what we have to calculate is the mid value. It's 0 to 10, 0 plus 10, 10 by 2 it's 5, 10 plus 20, 30 by 2, 15, 20 plus 30, 50 by 2, 25, 30 plus 40 by 2, 35. So likewise we find it out. Then what is the formula? That is x bar equals to sigma fxi by sigma f. And what is this xi? Xi is the mid value, f is the frequency, and summation sign it is given, sigma is summation. So we multiplied xi with the fi, 55, this is 240, 575, 140, 360, 1045. Keep this in mind. There is a myth regarding every student that for calculation of statistical values, the calculator are provided in the examinations. Neither in class 9th or 10th and in 11th, the calculators are strictly prohibited in the examination hall. So it's sigma fxi by sigma f, that is 2415 by 81. The answer is 229.814, which is equivalent to 29.81. This is how we could find the direct method of the continuous series. Let us discuss the assume mean method. For assume mean method, the same what I discussed in the discrete series, just we have to change this xi is included. So first we find it out the mid value, then we subtract. We take any, earlier we were taking here any number as assume mean. Also we could take from here, but for the convenient it is easy for calculation, we will take the assume mean from here. Likewise, I have taken 25. You could take any numbers. So we subtracted it. It's minus 25 minus 25 minus 20, 15 minus 25 minus 10, 25 minus 25 0, 35 minus 25 10, and likewise it goes on. And then we multiply the frequency with this. What mistake student used to create here, that they multiplied these two stuffs. Okay, never ever. This frequency and this multiply it. After multiplying, we add it on, and the sigma value of frequency value of sigma. Okay, after that the mean equals to assume mean plus sigma fxi, this value, by this value. So 25 by 390 by 81, it gives on 29.81. remember that whether we find the value of mean by direct method or indirect method or any method, the answer is always same. It never differs. Okay, so now let's move on to the next and the topic, that is the step deviation method. Remember that the width of this must be equal and there may be some similarities between the deviations. Otherwise it is very much difficult if we got a data 3, 7, 8, 9. Okay, like this, it is very difficult to take a common deviation from it. That is called the common difference or the common deviation from it. So for that, what we need is, we take, likewise I have taken in earlier question, I have taken 25 as assume mean. Now I have taken 35. So you could take any mean, any of the following of the mid value as assume mean, and you could solve that. So it's taking out the value 5 minus 35 minus 30, 15 minus 35 minus 20, 25 minus 35 minus 10, 35 minus 35 0, 35 minus 45 10, 45 minus 35 minus 55 20. So likewise we are just subtracting this, we get this value. So now we divided it, we get 10 as a common differences or the deviation we could take. So we divided it from d dash, that is giving the value minus 30 by 10 minus 3, minus 20 by 10 minus 2, minus 10 by 10 minus 1, likewise it. And then we multiply this value with this value. Remember this, never multiplied these two or these two. It will be multiplication of this value, and this is how we calculate that. The value of sigma fd is minus 42, and for that what we have to do is, the formula is sigma of arithmetic mean is sigma fd, that is this value, and by this value, and what deviation we have taken, that is this 10. This 10 will be multiplied here, and what we have taken assume mean, we have to add it on later. So taking out this, we multiplied it, the value is 5.185, and if we multiplied it, the answer is 29.814, which is similar to the value of 29.81. Remember, this d dash is the deviation and d is the deviation value. This is the deviation value which we have to multiply it with the frequency. Never get messed with this. Okay. So let's move on to a new one, that is the some miscellaneous mean formula, that is the formula of combined mean and for the correct mean. For combined mean, suppose there are the data is given of, for example, let's see that the mean of 20 observation is 46 and mean of 30 observation is 33. So we have to find out the mean of 50 observation, that is the combined mean. In order to find this combined mean questions, what we have to do is applying this formula. What is this? Sigma x, that is the arithmetic mean of series 1, 2, 3, that is the combined mean, is multiplying the mean of the first series, adding it to the second series of multiplication of mean and the number of observation. Likewise we going and dividing it by the number of observation. Clear? Let's make it clear with an example. So mean of 20 observation is given 46 and 30 observation is 33. We have to find the mean of 50 observation. So first what we have to do is, mean of 20 observation means 46 into 20, the number, it is n and it is x bar, plus 33 into 30, that is n and it is x bar, and dividing it by this n1 n2. Okay, n1 n2, that is 20 plus 30, that is n1 and n2. Okay, so let's multiply it. 46 2 ja, it's 9, to 0 plus it's 50. So the value will be 38.2. So one mean has a value of 46 and one mean has a value of 33. We have to find the combined mean. So the combined mean is 38.2. Clear? Now let's move on to the important topic, that is the corrected mean. Somewhere the formula is of the corrected mean is x bar c equals to x bar wrong value into the number of observation minus the wrong value plus correct value by number of observation. Let's take an example of it. Suppose mean of 20 observation is 36. Okay, and within it two values 14 and 38 were misread as 41 and 83. The digit got reverse, so they were misread. So the actual value was 14 and 38, but what we included in this mean, that is 41 and 83. So these are the wrong value. So the formula is x bar correct mean equals to x bar wrong into number of observation, that is 20 here, plus the correct value minus wrong value by number. So what is the wrong? That is 36 into 20 plus what are the correct values? That's the 14 and 38 are the correct values. And what are the wrong values? That are 41 plus 83. These are the wrong values. And what we have to divide it with 20. This 720 plus it's 52 minus 124 by 20. So 720 and we subtract it. So on subtracting we got it minus 72 by 20, or we could write it taking 72 as common, we get 10 minus 1 by 20. I am doing, as I am preparing for my competitive examination, so I used to do such type of stuffs. You could also make it effectively. And it's 36 9 ja, it's so this is the correct mean, but we got the mean due to misread value of this two. We got this, but actual mean is 32.4. So these are the basic sum formulas related to the measures of central tendencies, part 1 of the arithmetic mean. And later on we will be bringing on the next chapter of median and mode, in which we will be discussing the various part of median, that is the quartile value, percentile value, decile value, the partition value that are, and finding of the mode by imperial method or by the. And let me clear one thing, that mean can be solved algebraically, but it cannot be solved graphically. Lest we could solve the median and the mode graphically, but mean is only the part of measures of central tendency that we can't evaluate it with the help of graphical representation. Thank you all.